Hello everyone! In the last example we looked at doing some statistical work with independent data sets. This time we're going to take a look at using a paired data set. So Stevens Honda Buick automobile dealership often sells to husband and wife pairs, and the manager would like to check whether the sales presentation is viewed more or less favorably by the husbands and the wives. If it is, some new training might be recommended to the salespeople. So to check for differences, a random sample of husbands and wives were asked separately. So one thing to point out, because it is a paired test, so it would be like if me and 10 of my friends all went in with their wives to a thing, and he picked a random sample of 5 people. If I was picked, he would have picked my wife to go with me because we are a paired set. Although we wouldn't do that because it's a Buick dealership, and if I'm not buying a Jeep, I'm not going. But anyway, we want to check for differences in the random sample and to rate the sales presentation on a scale of 1 to 10, with 10 being the most favorable. So we want to calculate the difference between the husband and wife's ratings for each observation. So that's along the row. We want to calculate the paired sample confidence interval for the mean difference between the husband and the wife's rating. And then we're going to figure out what conclusions can we draw from that confidence interval. Okay, so here we have the data of the husband and the wife giving their ratings. So I want to go and I want to calculate out the difference between those ratings. So this one's easy, equals husband minus wife. So a positive rating means the husband rated it higher than the wife did. Negative would be the wife rated it higher than the husband. So there's our differences. Now, what I want to do is I want to know what the correlation between the data is. So remember, we looked at data before. So correlation, if it is a 1 or -1, it's perfectly positively or negatively correlated. Anything in between is just showing how one changes with the other. So what we're going to do is we are going to go and use our correl function. And so returns the correlation coefficient between two data sets. The first array we'll use is our husband data. Went too far. Comma, and then we will take a look at the wife data, put that together. So we have a correlation coefficient of 0.442%. Now that's not perfect, because remember a perfect correlation would be 1, but it's fairly high. And it's fairly high, and because it's fairly high, it's really showing that these two sets are paired and not independent. If we were seeing independent data, we'd expect something much lower than that. Okay, so what do we do now? Well, I want to figure out, so we want to calculate the mean and the standard deviation of the differences. So we're not going to look at the husband and wife, we're going to look at what the difference between them is. So mean, this one's good. So this is going to be our average of the difference column. In fact, so the last couple examples I showed how to drag equations around using the copy and paste method, and the last one I used locking stuff in. And I was thinking, especially for statistics, I think the easiest way to do it is my preferred method, which is giving everything range names. Let's do that right now. I want to quickly go into formulas. We're going to create from selection. I'm just going to highlight all these. Create from selection. I want to bring everything out of the left column. So I'm going to get the names out of the left column. And then I'm going to grab all these differences just to be complete. I'm going to grab that from the top row. Now if I go and click on this, this is sample mean. This is going to be a long one, but it'll be easier to see what's going on, at least in my opinion. So we're going to go to the average, and I'm going to want the average of the difference. And since I have difference in there, I don't even need to go highlight it because I know it's going to be the difference. I'll close that out. And so my average difference between the husband and the wife is 1.629. So on a scale of 1 to 10, on average, the husbands rated the presentation 1.629 higher than their wives. Okay, so we're going to go standard deviation of the sample, stdev.s, and once again, we're going to use the difference. And so our sample standard deviation is 1.664. So we have a standard deviation that's greater than the mean. And so the last thing that we're going to have is our sample size. So we're going to count. And I'm going to count the number of differences. And so we have 35 observations. Okay, so let's go to the next part. We have a confidence interval, confidence level of 95%. Our degrees of freedom. Now, this is a little bit different. So in the independent test, our degrees of freedom were the entire amount of things that we counted, and then we had two different rows that we counted. And so we had two sets of data, so that we subtracted 2 to get the degrees of freedom. In this case, it's going to be our sample size minus 1 because we have paired data and we've only got one column of data. So our degrees of freedom are going to be 34. So now we need to calculate our t-value. So we're going to run our student t-test. So t.inverse, because we want the actual value and we want to get both tails, so we're going to take the 2t test. So our probability, we want the probability that it's going to be outside of that, so 1 minus our confidence level, and then our degrees of freedom. So there's our degrees of freedom. And so once again, I like range names a lot. I use them a lot in my own thing, and this is part of the reason why. That's a lot easier looking at that equation going, oh yeah, that's what's in there. So anyway, so there is our our t-value for 95%. So let's go and do our lower bound. What's our lower bound? Our lower bound is going to be the sample mean. And we're going to go minus, because we're going the lower bound. So we have our alpha value. That is kind of a messed up name, but that's what we've got. We're going to deal with that. And so we're going to multiply that by our sample standard deviation. And then we divide that by the square root of our sample size. So there's our square root of our sample size. And I developed an extra parentheses in that I don't need. So our lower bound is 1.057, and so we're going to do the upper bound. We're just going to copy this down. And this is one where we could just, if we want, Control-C, Control-V, or we can drag it down, the same thing's going to happen. And we're just going to change that from a minus to a plus to get us the upper level of our confidence interval. So our confidence interval runs from 1.057 to 2.20, so 95% confident that we're going to land in between those two values. This confidence interval does not contain 0. It's completely above 0, so unlike in the last example where it was 0 and we said we couldn't statistically say anything about this, this one, they're both above 0, so we can say with 95% confidence that there is statistical evidence that the population means of husbands and wives ratings are different. For our car ship owner, it confirms his belief that there is some kind of difference. There is a statistical difference between the husband's and the wife's scores, so he might want to go back and go to his salespeople and try to figure out what they need to do to try to get those scores on parity. And there we have it. If you have any questions, please let me know. Otherwise, I will see you next time.